Assalamualaikum. I will present about projectile motion assignment. This is our group member. This is video for angle 1 by using software tracker. This is the result that we get from software tracker for angle 1. For graph x position versus time, the shape of the position x, again the time is upward. As the x position increase, time increase proportionally. It is because as the velocity of the projectile is constant, then the slope is also constant. This is linear function graph. For graph y position versus time, the shape of the graph position y against the time representing the equation above is a parabolic curving downward. The velocity in the vertical direction begins to decrease as the ball rises at its highest point. As the ball falls toward the ground again, the vertical velocity increases again in magnitude but point in the opposite direction to the initial velocity. It is polynomial graph. For graph Vx again time, theoretically Vx0 must be constant, but considering errors, the graph obtained is linear. For graph Vy against time, the shape of the graph Vy against time is leftward. It is because the ball is moving with a negative velocity. This is video for angle 2. This is result and data for angle 2. Video for angle 3. This is result and data for angle 3. Data analysis from software. The calculation for angle 1, Vx0 equal to 0.902 from manual calculation. The value of Vx0 of the graph from the software does not same as Vx0 of manual calculation. This is because external force is produced from the environment and the analysis tracker does not precisely detect motion. For y position versus time graph, the Vy0 equal 2.7347 from manual calculation. The value of Vy0 of the graph from the software does not same as Vy0 of manual calculation. This is because external force is produced from the environment and the analysis tracker does not precisely detect motion. For Vy versus time, the slope represents decrease in acceleration. The value is acceptable since the ball was subjected to gravitational acceleration, which pushed it downward. This is calculation of angle 2. Calculation for angle 3. Comparison graph for x position versus time of different angle. As the angle increase, x position decrease. For graph y position versus time of different angle, the angle has an impact on the graph highest peak. The higher the peak on the graph, the greater the angle. Graph for Vx versus time of different angle, due to error occurs, the Vx0 is not constant. Graph for Vy versus time of different angle, the deceleration of particle motion increases as the angle increases. By using this formula to calculate the percentage of error equal to Va minus Ve over Ve times 100%. So the percentage error is equal to 39.99%. From the conclusion, the data we observe, the percentage inaccuracy estimate that we receive is 39.99%. This inaccuracy happened as a result of external forces from the environment As a result, the data can't be accepted because the percentage error is more than 10%. Thank you.